So to answer the question of where it's increasing and decreasing, we're going to take our first derivative and we get 11x to the 10th minus 60x to the 9th. And again, this is a polynomial equation, so setting it equal to 0 is going to be a question of factoring. So we have to notice that it's a polynomial, and because it's a polynomial, we're going to want to try to factor. So the GCF here, 11 and 60 do not have anything in common, but the x to the 10th, x to the 9th, you would choose the smaller exponent of x to the 9th, leaving you with 11x minus 60. And then you set that equal to 0. So now that it's factored, we're going to set the x to the 9th equal to 0 and the 11x minus 60 factor equal to 0. Now to undo this 9th power, you would take the 9th root. Keep in mind that with the odd powers, you do not add a plus or minus, even if it had been like 1 here, for example. So you just get x is equal to 0. And then over here, you would add 60, divide by 11 to get 60 over 11. All right, so to find out where it's increasing or decreasing, we're going to take our first derivative, it's critical numbers, the critical numbers of 0 and 60 over 11, and test a number to the left and to the right. Now, remember, you can plug into this formulation of the derivative, the 11x to the 10th minus 60x to the 9th, get an actual number for it, or you can focus on the formulation after you take the derivative and factor it. So the x to the 9th times 11x minus 60. And it's totally up to you which way you want to go. All right, so here I'm going to focus on the factored form. Let's say I start off by plugging in -1. Okay, so if I plug in a -1, I have -1 to the 9th, and then 11 times -1 would give us -11 minus 60. So this second parenthesis evaluates to a negative. The -1 to the 9th would also evaluate to a negative. So here I have a negative times a negative, so that's going to give us a positive on the first interval. All right, so then from 0 to 60 over 11, I might decide I'm going to plug in, let's say, +1. So I get 1 to the 9th. 11 times 1 just gives us 11 minus 60. So we're looking at a positive times a negative, so that gives us a negative. All right, so the 60 over 11, I mean, you might have to actually punch that in on your calculator to figure out what 60 over 11 is, or you could plug in something that you know is going to be to the right of that. Maybe I plug in, let's say, 100. So if I do that, I would have 100 to the 9th, which is going to be a positive, and then 11 times 100, so that's going to be 1100 minus, and then the 60, which will give us a positive. So we have a positive times positive, so we're getting a positive. All right, so now we have to look at this little chart here and figure out how we're going to write our answer of increasing and decreasing. So the positive would indicate that I'm going up until that critical number. The negative indicates that I'm going down until the next critical number. And then the positive tells us that I go up. So we would say that it's increasing from -infinity to 0, union 60 over 11 to positive infinity. And then we would say that the function is decreasing from 0 to 60 over 11. And keep in mind, for all of these questions, you always use parentheses for the interval. All right, now the relative min and max. The relative min would happen at x is equal to 60 over 11. And the relative max, if you just look at the structure of this chart, would happen at x is equal to 0. Okay, and if you wanted to find the actual y values, you could plug these x values into the function, the original function, to find those relative min and max y values. But it's perfectly fine for your test to write your answer in this formulation.